I watched a really interesting documentary the other day. It's about people who subscribe to the theory that the Earth is flat, and it's fascinating. It's called Behind the Curve. It's on Netflix right now. I put a link in the video description below, and I recommend watching it. After having watched the movie, I did some background research to learn more about flat Earth theory and round Earth skeptics, and I was particularly intrigued by several experiments that were conducted by skeptics to falsify the theory of a round Earth. Specifically, I came across a YouTube video showing this wonderful photograph taken with a high-resolution camera and near-infrared filter. I put a link to the original video where I found this in the description below. It shows Mount San Jacinto, east of Los Angeles, California, as seen from Point Dume on the Malibu shore, about 200 kilometers away. Since 3D visualization of Earth science data is my bailiwick, and I had some data lying around, I wanted to test if I could recreate this photograph using 3D computer graphics and therefore falsify round Earth theory. This here is a 3D viewer application for high-resolution topography data that I created like eons ago, showing a detailed 3D model of California and bits of Nevada at approximately 10-meter resolution, give or take. It's quite amazing, the stuff I have lying around on my hard drive. Now, this particular viewer application uses a flat Earth model, and you can see if you look here from the side that California is completely flat with a bit of topography sprinkled on top. Just ignore these sheer cliffs of doom here. Those are just the boundaries of where I downloaded elevation data. The data set is already 50 gigabyte as it is. I didn't want to waste any more bandwidth and storage space. Okay, this here is Malibu. And before we go on, I want to measure the distance from here, which is Point Dume, where the picture was taken, to Mount San Jacinto, to see if this model is actually to scale. I put down a measurement point here, and then we go over all the way to here. This is Mount San Jacinto. Get a bead on that, put another measurement point down, and then it tells us the distance is 197 kilometers, which is about exactly right. So that's great. So now let's try and recreate the photograph. Based on the description from the photographer, I need to get my marker right on there. Based on the description from the photographer, the picture was taken from the top of these cliffs, but not from all the way up this hill, because apparently it was windy that day. So I'm guessing it is from approximately there. Now I'm going to use the scale bar to change the scale all the way to 1:1, but oops, before we go on, need to change a few settings to make it look better. So we're going to use a sunlight source coming from an angle of 200 degrees azimuth and 35 elevation. That's a nice summer afternoon. Get this here in the corner, and then keep scaling in 1 to 10, 1 to 5, 1 to 2, 1 to 1. And then I use a walking tool to put myself on the ground, and then we look up and in a generally easterly direction, and voila, there is the mountain. Now, right now, clearly it doesn't look like much, and it's going to get worse as I start using a telephoto lens to zoom in a bit. Alright, this program is a multi-resolution viewer, meaning that it shows faraway objects at reduced fidelity, but I can change these rendering settings here to bring in more detail and show it in a much better quality. And there it is, ta-da! Now this is the view of that photograph recreated as closely as I can in this particular program. Now let's overlay the actual photograph with this rendering in order to see how similar they really are. And as you can see, it's about as spot on as it gets. Obviously my viewer doesn't have any buildings on it, or birds for that matter, but the Santa Monica shoreline, the intermediate foothills, and then most importantly, of course, the shape of the mountain line up pretty perfectly, I would say down to the pixel. So that's fantastic. As a side note, this also means that the photographer was using really good equipment, a great camera lens combo with no visible lens distortion. My viewer, using a virtual pinhole camera model, has no lens distortion whatsoever, of course. So what gives? Does this mean that does this prove that the Earth is flat? Well, I wasn't exactly honest earlier. I forgot to mention something, and that is that this viewer program here can use both a flat Earth model and a round Earth model, and we were doing this whole thing in round Earth mode. So if I show you this from the side, you can see how California is slightly curved, and this curvature is appropriate for living on a hypothetical sphere or globe with a radius of approximately 6,400 kilometers. I have a slider in this rendering dialog here where I can change the size of that globe from what it really is to completely flat, to globe, to flat, to globe, to flat. You get the idea. Now let's go back to Point Dume and see what it looks like when I use a flat Earth model to recreate that picture we were looking at. So I'm just going to go back and place ourselves onto the more or less the same spot where we were. I'm not going to match it exactly, but you know, just bear with me there. I need the scale bar again. Alright, let's see. I'm going to zoom in to 1 to 1, get rid of the scale bar, put ourselves on the ground, look up at the mountain, there it is. Reduce focus and context, zoom back in. Okay, so again, this is the view, the virtual view of the mountain using a round Earth model, using a globe with a radius of 6,378.1 kilometers. And now I'm going to slowly change to a flat Earth model, and then we can see what the differences are. And whoa, okay, that's amazing. That is a huge mountain, and you can see that by just changing this back and forth, we are suddenly seeing about approximately 2,400 meters more of that mountain, as if we were using a curved Earth model. So just to be entirely certain about this, this is a rendering that matches an actual photograph which is based on a round globe, and this would be what that photograph should have looked like using a flat Earth model. So what does this all mean? Does this prove that the Earth is round? No, it does not. The round Earth theory made a testable prediction, namely that a certain mountain would look a certain way when photographed from a certain distance, and then an experiment, in this case a photograph, matches exactly with that prediction. So that doesn't mean that the Earth is round, it doesn't mean that the round Earth theory is true, but it also definitely doesn't mean that it is false. On the other hand, flat Earth theory also made a prediction, namely that the mountain, when photographed from this particular distance, should look like this, but then in the experiment, the actual photograph, it ended up looking like this. So that unfortunately did not work out. This does not mean that the Earth is round. It just means that flat Earth theory has some splaining to do. It is completely conceivable that there are some effects that would make the Earth just appear to be curved, even though it is not actually curved. Maybe we have to rework our understanding of how optics work, but that is not for me to speculate. Okay, in conclusion, thank you very much for watching the video. Remember to like and subscribe, and please do not block the ads. Daddy needs a new graphics card.